resolving forces and using the fact that resultant force is 0. So just to start with, one important fact it tells you is that the figure is stationary. Why that's important, it means that the resultant force is 0 because forces are balanced in every direction. If the forces weren't balanced to the right, like if there was a larger force to the right, that would make motion to the right. If there was a larger force downwards than upwards, then that would make motion downwards. But then because it's stationary, that means that the forces are balanced horizontally and vertically. It tells you the tension on each of the wires is 15 newtons. Tension always acts up the wire. And it says at A, calculate the resultant, that's very important, horizontal component of the tension forces. So at A, I'm just going to draw this out here. There's a horizontal component of this tension in this direction here. But how do we find that horizontal component? Because this 15 newtons, of course, is acting at this angle above the horizontal. You actually draw your own right angle triangle in an exam. This angle here is 20 degrees. I'll make that a little larger actually. So this angle here would be 20 degrees. There's a 15 Newton force going up the tension, it's the rope, sorry. And we want to find this horizontal component, let's call it X. Well, because it's a right angle triangle that we made, we actually use SOHCAHTOA, where this is your adjacent, this is your hypotenuse. So we can say cos of the angle is equal to the adjacent, which we're trying to find, X, divided by the hypotenuse of 15. Multiply both sides by 15 and get that X is 15 cos 20. Meaning the horizontal component to the left is actually 15 cos 20. Now there's another tension which acts, and that also has a horizontal component which we have to calculate. And it will be the same right angle triangle, just in the opposite direction. So it would be like this, and what you'd get is that the horizontal component in that direction is also 15 cos 20 degrees. Now this question asks for the resultant. Resultant means you take one of the forces, the larger one, and you take away from the smaller one. But because both are the same size, they end up cancelling out, giving you a resultant horizontal component of 0 newtons. So that's the answer to the first part. Now let's move on to the next part. So now it's asking for the resultant vertical forces of the tension. So both these tensions, they also have a vertical component. It goes in the same direction, so we'll talk about what that means, because before the horizontal components, they went in opposite directions, so they cancelled out. So in this right angle triangle that we've drawn, we now want this vertical component, let's call it y. Using this opposite and the hypotenuse, we can use sine and say sine of 20 is O divided by H, y divided by 15. Let's do that here. Sine of 20 is O divided by H, y divided by 15. Multiply both sides by 15 and we get y equals 15 sine 20. So there's a force of 15 sine 20 acting upwards. Let's label that on this diagram here because it's acting on A. So there's 15 sine 20. And also, because of the tension on the other wire, and because the angles and the force on the tension is the same, there's also going to be another 15 sine 20 acting because of the tension on the right. Now, because they're acting in the same direction, the resultant is what you get when you add up the two individual tensions. So you do 15 sine 20 plus 15 sine 20, and that will get you 30 sine 20 degrees. I'm just going to leave it in this format now, just because I think I may have, yeah, I left my calculator downstairs, but you can just put your value into the calculator and it will get you the right answer. Now, moving on, before we just focus on the tensions because it asked us to. Now it's asking for the weight of the metal block. Before I mentioned it's stationary, which means that forces are balanced. We already know that the forces acting horizontally are the tensions, and they're balanced. It shows that they're balanced. But here, the tensions acting upwards, they're not balanced because there's no force acting downwards. But in reality, there's the weight acting downwards to balance it out. So the weight is just equal to the sum of these two forces. so that the resultant force can be 0, and so the object can be stationary. So it's just 30 sine 20 as well. That would be a 1 mark question. And then there's also this explanation here, which is a 3 mark question. I think it just got rubbed out. Saying how you arrive at your answer with an appropriate law of motion. So here, resultant force is 0. That refers to Newton's second law of motion. So I'm just going to get a text box here and type up what would be a model answer. So Newton's second law of motion. It's just messing about with me. Let's try writing it out. You might see me write N2L, that just means Newton's second law of motion, but the equation referring to it is F equals ma. Now F stands for resultant force, so we'd say that the resultant force is 0, or it has to be 0, for an object to be stationary. Your first mark is for mentioning Newton's second law, your second mark is for mentioning that it has to be 0 for an object to be stationary. And your last mark is for mentioning that if the resultant force is 0, that means that all forces must be balanced, which means that the weight going downwards is balanced by the sum of the upward forces, and the horizontal component of the tensions are also balanced. So upward forces are balanced by the downward forces due to Newton's second law of motion. That'd be a third and final mark. Hopefully that made sense, and if you have any questions about this question, just please let me know in the comments. Thanks for watching. Have a good day.